that okay? Yes, ma'am. Combining, or you could say adding and subtracting fractions. That's it. This is just adding and subtracting fractions. It's an easy title, but it's a more complicated process. Adding and subtracting fractions. Let's look at another one that has a very special application. 61. It's observation time. That's right. Did you see the opposites in the denominator? Did everybody see the opposites? All right. They should start becoming natural as far as your observation processes go. X minus 2, 2 minus x. Now remember, those are opposites. All right. Here's a concept, and it's a concept you're familiar with. I'm just going to put some words to it. A number is the same as -1 times its opposite. Is that true? Is 5 equal to -1 times -5? Yeah. A number is the same as -1 times its opposite. A number is the same as -1 times its opposite. A number is the same as -1 times its opposite. Let me write that down. A number? What? What did I do? A number is the same as -1 times its opposite. And that's the truism we're going to use to change this fraction so that the denominators are not opposites or close, but identical. That's when I can combine fractions, and the denominators are identical. So I'm going to make a little substitution. And I can substitute for either one of these guys. I think I'll substitute for this guy right here. I'm going to change this guy out for -1 times its opposite. Okay? So 3 over x minus 2 plus 5 over. Now 2 minus x is the same as -1 times its opposite. Right? I made that substitution. 2 minus x is the same as -1 times its opposite. Hey, remember what we just observed about fractions? I can have the negative downstairs, upstairs, right in front. Whatever is convenient for you. Well, it's convenient for me to put it out front. So instead of down here on the bottom, I'm going to put the negative right there in front of the fraction. So instead of a plus a fraction, I'm going to have minus a fraction. See what I did? I can put that negative anywhere I want. So I chose to put it in front of the fraction instead of downstairs. Now, doesn't that look simple? I have the same denominator, 3 minus 5. I can do that in my head. 3 minus 5 is -2. So I get -2 over x minus 2, or probably -2 over x minus 2. So I've got the same denominator, combine your numerator. You do. Yes, sir.
Yeah, you said you could do either one, so but if you did 3, you would have positive.
Actually, I would have a positive 2 over 2 minus x. I'd have a different denominator. I'd have the opposite denominator. And that would have been fine as well. So, here's another way to think of it. I've got negative 2 over x minus 2. I've got negative 2 over x minus 2. If I would multiply top and bottom by negative 1, I would get 2 over 2 minus x. Or I could put negative x plus 2, but typically we write the positive value first. So that's what I would have gotten if I would have changed the first fraction. Same thing. Same thing. I'm just multiplying by 1 here. So it's the same thing, just a different way to express it. That's a good question. So those are the same. Hey, here's the good news about your test. You know how many questions you're going to have adding and subtracting fractions? Yeah. All right. So, got to use my time well on these problems. I only got 50 of them to go around, so we're not going to do any adding and subtracting fractions. But I want you to be familiar with it, because you're going to have to do it sometime in some places, but there just won't be one on the test. All right, our final concept in this section deals with something called compound fractions. Compound fractions. That's when you got fractions in your fractions, all right? You got fractions in the numerator, you got a fraction. It's like adding insult to injury for those people that don't like fractions. You got fractions all over. Here's an example. They're called compound fractions. I'm going to show you two types. And you approach them differently, so it's nice to know, nice to observe which type is which. Type 1 is just a fraction over a fraction. One fraction over one fraction. Like this. See what I mean about adding insult to injury if you already don't like fractions? This is considered unsimplified. A compound fraction is considered unsimplified. Fractions are fine, but not fractions in fractions. All right, here's the strategy for type 1. Notice it's just a fraction over a fraction. That's all it is. Another way to write this, another way to think of this division bar is divided by. So I can simply re-express it as this divided by that. Right? That's all a fraction bar means is divided by. Oh, yes, it is. I'm sorry. I get so excited. It's type 1. That's 2x, 2 minus x over x. Hey, that's familiar turf, right? A fraction divided by a fraction. That's equal to the first fraction. Times the reciprocal of the second fraction. Now, all I got to do is factor and simplify. How does 4 minus x squared factor?
It doesn't.
Thank you. That's the difference of two squares. You don't usually see it that way. It's usually x squared minus 4. But hey, we're open to new and inventive things. This is just still a difference of two squares, so it's square root of the first guy goes there and there. Square root of the second guy goes there and there, plus and minus.